Hey everybody, and welcome back to another fun and exciting Algebra 1 class. Today we're going to be looking at the final lesson in chapter number 7. That's lesson 7.7 on page 245. On page number 245, you're going to see this last lesson. I'm really not going to teach anything new, but what I'm going to do is we're going to go over some general strategies. And what I mean by strategies, when you just get a question on a quiz or a test that says factor this, well, it's not going to tell you this is a perfect square trinomial. This is a difference of two squares. This needs to be common factored first, whatever. It's not going to tell you those things. You're going to have to come up with those things on your own. So I'm going to give you here some general strategies to help you to do this. I would write these down, and you don't have to write them down verbatim like every single thing, but I've also got them here in on my tablet, and what I'm going to do is we'll just go through them. You can write them down. I'll try to blow them up just a little bit so you can see them, but we'll go through them and just kind of piece by piece, and then we'll do a couple of these and go from there. So starting off here, number 1, general strategies or tips for factoring. Number 1, always begin by checking for and factoring out any common monomials. Okay, what does that mean? I've been telling you this ever since we started factoring. Common factors, greatest common factor, GCF. Okay, that is number 1. That is huge. You have to start there. If you jump to question, or excuse me, if you jump to number 2, if you jump to the second step, you're in trouble. Why are you in trouble? Because you're going to look at it and you're going to get confused. You're going to have to do a lot of extra work, and you could have saved yourself all of that if you would have just tried to factor out the common factors first. All right, number 2, there's lots of stuff going on with this one, so let's look at this. Number 2, the choice of factoring method is most often determined by how many terms the polynomial has. Okay, what does that mean? So if it's 4 terms, then you're going to have to do what? Okay, we've only done one thing that includes 4 terms. What was that? Do you remember? That's right. We need to take it and we need to group it. So we need to group 2 things together or group 3 things together. That way we can figure out as a trinomial or as a binomial, whatever we need to do. So by grouping, if you have binomials, then we're going to really, the only one that we've looked at with binomials is the difference of squares or just a common factor. For trinomials, we want to see if we can, what the 2 factors of the A and the C, right? And then see if it adds up to the B. What are we looking for there? Is it a perfect square? Be alert, it says, for the opportunity to apply the perfect square trinomial shortcut. That's the one we learned in the last lesson. And then for polynomials of 4 or more, we're going to group them. So in other words, with this step number 2, this tip number 2, what you want to do is you're trying to say, okay, what is this? What am I looking at right here? All right. Number 3, the polynomial or its factors are considered prime when nothing really works. So when you're trying things and you can't figure out anything, then just use this word right here. We haven't dealt with many prime yet, at least on the videos. We haven't dealt with many prime. You may have gotten some of those in your practice problems that you've been working on. But prime means it cannot be factored with any of the methods that we've been teaching, okay? Number 4, so we always want to factor completely. What does that mean? Do not stop factoring until all factors are prime, until you can't do anything else. So don't pull out the common factor and say, oh, I'm done. I found the common factor. Well, after the common factor, you might have something else to do. You may have a difference of squares, or you might have you might be able to pull out something else. You might be able to factor it again. Okay. So never stop until everything is already fully factored. And then the last one, is just how to check it, and factoring can be checked by multiplying the factors together, by foiling, by distributing, by doing whatever you need to do there. All right. So those are the strategies that we're going to use. Make sure that you write those down in your notebook and you take the time. Those are on page 245 as well. All right. So the next question that gives you the example on page number 245 is 6x cubed plus 3x squared minus 18x. Now, one thing that you should be noticing is when we see something weird like a cube, we haven't factored anything with a cube yet, so we don't know how to factor those. In Algebra 2, you will learn how to factor some cubes and things like that, but for right now, we don't have a method for that. We don't know what to do. So you should be thinking, oh, okay, this is either going to be prime or I can pull out a common factor. So always start with common factor. Don't just jump to prime. Could it be prime? Yeah, it could be prime. But always start with common factors. We're looking for a GCF, greatest common factor. Let's look at the numbers. So 6, 3, and 18. Well, does 3 go into 6? Yeah. Does 3 go into 3? Yeah. Does 3 go into 18? Yeah. Well, 3 is your greatest common factor because it's the biggest common one. So you could say 6. Well, 6 goes into 6, but 6 doesn't go into 3. So 3 is your GCF, okay? That's the number GCF. Now what about the letters? We have an x cubed, an x squared, and an x. So you always take the smallest letter. So it's going to be 3x is our GCF. We're going to divide everything by 3x. And that's how we factor the common factor out. So what do we get here? We get a 2. What do we get here? We get an x squared. So 2x squared. Don't forget that we have 3x. That's our common factor, greatest common factor. So it comes outside, and that needs to be there. If that's not there, then your answer is going to be wrong. Then we have a plus sign, so we'll put a plus sign, and then this factors to 1, this factors to x. So just x or 1x. You could leave the 1 there, that's fine, but you don't have to write it. And then we had a minus, and that's going to cancel to a 6, and the x is just going to cancel, so 6. Now, some of you might be tempted to stop there and say, okay, I'm done. I don't have to factor anything else. I've got my common factor. I'm moving on with life. Here's the problem with that. Well, one of your strategy tells you not to. Always factor completely. Do not stop factoring until all factors are prime. So we can't do that. We have to keep going with this. All right, so what else could we do here? Well, we can look at this and we can say, is there anything else I can do here? Is there any other factors that are contained inside of this trinomial? Well, I don't see that it's perfect squares because 2 is not a square. 6 is not a square, so it's not a perfect square. So what we're going to need to do is we're going to need to try some different things here. So let's try what are some factors of 2. So the factors of 2 would be 1 times 2. What are the factors of x? It would be x times x. What are the factors of 6? 1 times 6. 2 times 3. What are our signs? Negative, positive. That means that we're going to have one negative and one positive. So we'll have one of these will be negative, one of these will be positive. We don't know which one yet. It just depends on what gives us this middle term that we're looking for, this 1x. And so what I would do is I would just kind of start working these. So 1x and 2x. So 1x and 2x. Don't forget this 3x out here is still outside. We can't forget him. Our common factor does have to go outside of this. And then over here with our 1 and 6, I wouldn't use that one first. I would start with the 2 and 3. So a 2 here and a 3 here. Again, we're just testing things because it's a puzzle. We're just trying to figure it out. And now what we want to do is we want to do our outers. And so doing our outers gives us I'll do them up here, so that gives us a 3x. And then we do our inners, and that gives us a negative 4x. And so combine those, and that gives us a negative x. negative 1x. Well, we have a positive x. Oh, do you remember what happens when we have the correct answer but the wrong sign? That's right. We just need to flip those signs. We just need to take those signs and just move them. And so I'm going to come over here and erase this minus sign, erase this plus sign, and we're going to switch them. So this is going to be the plus, this is going to be the minus, and we're going to try that out. So here we go. The outers is going to give us a positive 3x, and then the inners is going to give us, oh, excuse me, I said that wrong. It's going to give us a negative 3x because that negative's there, so negative 3x. And then this inner is going to give us a positive 4x. Well, here you have it. We end up with a positive 1x or just x, and that is what we have here in the middle. So, in other words, this is going to be our answer, 3x. And then I would never write that 1x there. I would always just go ahead and erase that, not write that as part of your answer, because it's not really proper to write the 1 in front of it. You can, it's not necessarily wrong, it's just understood so you don't have to write it. So x plus 2, and then 2x minus 3, and that would be your correct answer on that one. Okay? Now, I would do this, and you might say, well, how do you know we're done? Well, what you do is you say, anything common here? No, nothing's common. Can I factor anything out of an x plus 2? No. Can I factor anything out of a 2x minus 3? No. So as soon as you get down to everything is prime, there's nothing else that can be factored, then you're done with that, and you can move on. All right, so the next one they give you in your book is going to be an x cubed minus 4x squared minus 9x plus 36. Now, we go back to our strategies that we learned and we say, okay, let's always check by factoring out any common factors. So let's go back down to this one and say, is there anything common in all of these? Let's check the x's, because the only thing in this is an x. There's no numbers in this one. So, oh, yes, this one has an x. This one has an x. Oh, this one does not have an x. So we can't put an x there. We can't just like make something up. So it doesn't have an x. So that's not common. And notice this one has no number. So there's no numbers common. We can move on. We do not have any common factors in this. Step 2, we want to choose what type of factoring method that we're going to use. So do we have binomials? No, we actually have 4 terms. So we have a polynomial. Notice this says for polynomials of 4 terms, attempt factoring by grouping. So now we need to go back to our factoring by grouping to try to remember how to do this. And so what we're going to do is just kind of choose 2 different things, and you kind of want to put things together that we can factor things out of. So right here and right here. Now, this is going to be a problem for us, but we'll deal with that when we get there. All right, so one thing that I told you was you always look to see what you can pull out, and some things that we can pull out of there would be on this one, we can pull out an x squared. So x squared comes outside, okay? And what's left over? We're left with an x because we're dividing everything by an x squared. We're left with an x minus, and then we have the 4 and nothing. So just x minus 4. Now, if you remember something from the factoring by grouping, this negative sign does something to this. And I told you that when we do this, we want a plus sign between these. So I'm going to kind of go over here and let's actually put that grouping inside, and then we're going to put a plus between them. That is actually an important step to what we have to do. And so this is, we have to make sure that the negative goes inside, and then we insert an addition, because we're adding a negative 9x. And so if you don't do that, you're going to get the wrong answer. So just make sure that you put that step in there. And so now what's going to come out? What do we want to come out of there? Well, we want the negative sign to come out. right? Okay, we want this to come outside because we want this to be a positive. So we want our what we divide out of this is our common. We want a -9 to come out of that. -9. Okay. And so what pulls out of there is going to be a -9. All right. And then we are going to have left over inside that cancels out, and that's going to be that cancels out, and it's going to be an X. Okay. And then we are left with this over here, and we get a -4 out of that. Notice that we have two -4s, so when we do factoring by grouping, we get an x squared minus 9, and we get an x minus 4. And you might say, I thought we had two x minus 4s. We're actually pulling that outside of that. And that might help. Let me write that backwards, okay? So maybe that would help you to see what we're doing there. Since we have this and this in common, we're pulling that out. We're undistributing that. So that's going to be an x minus 4. And that only comes out one time. So like when we pulled out our x from x squared from here, we only brought out the x squared. We only brought it out one time. So again, that you might seem like you have two of these, but you don't. You have one because it's all multiplied. And then what are we left with? X squared minus 9. X squared minus 9. Hopefully that makes sense to you. Now, some of you are thinking, oh, I'm done. X squared minus 9. Okay? And x minus 4. That's my answer. Let's go back to our steps real quick. Always factor completely. Do not stop factoring until all factors are prime. Well, guess what? We need to look at these and say, is this prime right here? And the answer is yes, that is actually prime, x plus 4. Then we look at this one and say x squared minus 9. X squared should be a sign to say, that maybe is not prime. Let's look into that. What do we have? X squared is a square. And 9 is a square, right? So x times x and 3 times 3. Okay? And then we have a difference. What we have here is a difference of two squares. So we have x minus 4. That's this one. And then this one is going to factor out into x plus 3, x minus 3. That factors out into a conjugate. Okay? And so this would actually be our answer now. X minus 4, x plus 3, x minus 3. How did we get that? We just kept following our steps. So make sure that you have those steps memorized. All right, last one. 3x squared plus 5x plus 1. All right, so common factors. We're going to look this over. I don't see anything that's common in there. We can look through it. 3, no. X, no, there's no x here in this last term. So I don't see anything that's really common. So let's start trying to factor it. Up here we have a 3 times a 1, and we have an x times an x. Over here we have a 1 times a 1. And so now we just start plus plus, and so now we can try to see if we can get this thing to factor out. So plus plus, 1, 1, that's easy over here. We can't do anything with that. And then we can just put these in. So 3x and a 1x, okay? Now, some students would just do that, and they'll circle that, and they'll say, we're good to go. Do not skip this step. This is a very important step because you might think, I used all my factors over here, so I don't have any really other options that I can do, and so that must be the answer. I'm just going to circle that. That's the answer. But there is another possibility. Remember, we have to get this middle to work out. So if we do outers and inners, what do we get? We get 3x plus 1x, and that equals 4x. In other words, this does not equal this. So that can't be the answer. So what would we do at that point? Well, we would switch some things, but here's the problem. When we switch this, and let's make this an x and this the 3x, well, it didn't change anything because now we still have 3x plus 1 and x plus 1. And before, what did we have? We had 3x plus 1 and x plus 1. We didn't change anything. So there's no real combinations. We can't change the plus sign. Why not? Because these are both plus plus. So we can't just add negative signs to it. Well, guess what? We can't get this middle term to work out. So this one is prime. This one cannot be factored. There is no this, and so this is wrong because this middle term didn't work out. It is prime. There is no solution to that problem. Okay? So lots of different things in there. Make sure that you're paying attention. Make sure that you're working each one. You're going through those steps. And yeah, are these easy? No, no, it's algebra. Algebra is the most difficult class taught in high school. More people fail algebra than any other class in high school. It is a difficult class. This is a difficult chapter. If you're thinking right now, man, this is so hard. Yeah, you're right. So it's going to take extra work on your part, and you're just going to have to keep working, keep digging, and keep trying and doing your best. Okay, so if you missed anything there, make sure to slide it back, watch it again, and watch the other videos. Go back over those and refresh how you do all these different types of factorings. Okay, that's all I've got for you. Hope you have a good one. We'll see you later. Bye-bye.